Hi, I'm Sean Hammond with PremierGuitar.com. We're here in Nashville, Tennessee at the Gibson USA factory, and we're about to go in and take a cool tour where you're going to see every piece of a Gibson made, every step of the process. It's pretty cool, pretty intense, and I think you'll dig it. Let's go inside. Okay, Jim, so we're here in you have a few different buildings here at Gibson. We're in the mill, I guess you call it.
This is called the rough mill.
And we have rough blanks of all sorts of wood coming in here. And tell us what's going on behind us, or in front of us.
We take our raw materials, all our wood stock comes in, as you can see, in large pieces, and we take the lumber and we rip it down into the appropriate size materials that we need, whether we're processing neck blanks or guitar body blanks.
What are we looking at right here?
Right now we're looking at raw mahogany lumber. When it's this size, it's most likely going to be guitar body blanks, and then he'll cross-cut that into the smaller sections. From there, they'll get further processed and surfaced. Along the processing, as we saw earlier, when they're ripping and cross-cutting the blanks into smaller sections, now they're doing the same thing but shoring up the edges so then they can be glued up. They're marking them as they come off. So they're grading them and marking them to see if they'll yield a two-piece body or a three-piece body blank. They look at the quality of the wood. If they see certain imperfections, mineral streaks or knot holes, those are cut out. The smaller pieces are then put to the side and culled, and then they utilize those to determine if they're going to be in a two-piece blank or a three-piece blank. Now we're looking at our glue clamp. As you can see, it rotates so it can accommodate a very large quantity of body blanks. By the time they're filled and loaded, then there's that glue time is kind of built into that operation, and then they start to pull them off and stack them.
Looks like you could probably fit, 100 on there or something?
Actually, the capacity is 118. The roller has glue in there, so they run it over that, and that applies the glue, and then they're stacked into the clamps, and then they have the pneumatic clamping where it's tightened down pneumatically, and then they have another clamp or fixture that makes sure that they're pressed down. It's pretty amazing when you see him pick up the blanks like he just did. He had 3 body blanks that he all picked up and put the glue on and just kind of tossed them down. And he's been doing it for so long, you can see they don't shift. He knows just how everything is to be aligned, and he can operate it, with incredible efficiency. We're just using an aliphatic-based wood glue. We've used it for many, many years, tried and true, and industry standard. Here we have a pallet of tops that are glued up. So these have just been glued, but they're not yet thickness sanded. You can just see it's immediately after the gluing operation.
Are these book matched maple then?
Yes, these are book matched maple, 2-piece tops.
How many tops can you get out of that? Because it's fairly thick. That's like a little over an inch thick, it looks like. Is it still just one top?
Yeah. Each of those would be 1 top per guitar. So here, he's taking a pattern and penciling out the body perimeter and then bandsawing them. You can see he has 5 or 6 at a time, and he'll rough them in on the bandsaw all at one time to prepare them for being milled on the NC machine. And what that does is remove a lot of the excess material, which makes the NC operation a lot more efficient, and it makes it easier on the machine as well. The bodies are heavy enough. They're just stacked on top of each other. There's no pins or anything. And the pattern is oversized, so he's just roughing it in. Our new weight relief here that we're looking at.
This is on the new standard that was unveiled at Music Messa 2012?
Yes, it is. The new standard in studio will have this new weight relief. It's a little bit more solid through the center, as you can see. We've done that because some people requested that it was more solid. They were afraid that maybe the chambering affected the tone and maybe affected the sustain and maybe feedback at high volumes. So it's more solid, yet still weight relieved. The chambering was used on our 2008 Les Paul Standards and Studios. And then the traditional route, which is a series of holes, is used on our Les Paul traditionals.
Now, this 2008 one, is that still being used on some models?
We're still using that on the 2008s that we still have orders for, that we're still making.
How did you guys arrive at these different patterns?
We use CAD programs that allows us to analyze how much material is removed, and we can use that information to determine where we want to remove it and design around. Like for instance, the long slot you see is our switch access cavity. So that way we don't have to drill a hole that is milled from the top. So we use that, the CAD program allows us to see that and design it from the beginning. He's feeding the tops into the glue roller. As you can see, right now that's applying the glue. The top that has glue applied is then loaded into the clamp. So all the bodies are loaded and stacked in here, and then the hydraulic clamps come down and glue them all together at the same time. Before the top is applied, has the locating pins, and then the top has the locating holes, and that keeps the top and the back from shifting as they're glued. Right now, this is our Northwood CNC body router, and we're routing SG61 bodies. We have 5 heads running at one time, and we have 2 tables. We'll run the backs on one side, and then we'll flip it over and run the tops. Everything you can see with CNC is very uniform, very precise, very efficient. We've had these since the late 80s, I believe, and like you said, it is the norm for the industry now. Gibson were certainly early in acquiring these machines and technology. Depending on the model, some models are a lot more extensive than others. The average cycle time is probably 5 to 10 minutes, depending on the model, and that's a total accumulated time, from doing both sides. We have all the different cutters that rotate, so you don't have to have separate setup times and delay things. They're on a turret head. They rotate depending on the operation required for that body.
For different sized bits and everything.
Correct. Some will be drills, some will be different size router bits or shaper heads. You can see right now they're using a small router cutter, and it's doing an operation for the control holes called interpolation. And that means they can use a smaller bit and program the diameter of the hole, so they don't have to have a separate drill for each of the holes required in the body. For instance, the toggle switch hole will be larger diameter than the pot hole, so this will just interpolate that hole with one bit. So this mahogany lumber that we get in is size, rough size for our neck blanks. It's a lot smaller than our body blanks. So it will go in the kiln for a specified period of time until the moisture content is at the level where we can process it. The wood is stickered. You can see the little slats of wood in between the neck blanks.
The spacers?
Yeah, the spacers. And they're called stickers, and they're used to allow airflow between the wood blanks. So that way the drying will be even throughout the thickness of the material. Here are another of our various kilns. You can see wood of different size, are processed here. It just increases our capacity and can better utilize the kiln process for specific sized raw material. That's actually water vapor that we use to environmentally control our facility. You'll see that in the rough mill, and you'll see that in our other plant as well. We constantly monitor moisture content in the air, and depending on the climate and what needs to happen, we'll have the vapor turned on for a period of time, and that will get our humidity level to an acceptable level depending on the time of year or the day. You can see the neck blanks are roughed in on a bandsaw, and then the peg head ears are matched and then glued on to the sides. After that, they'll be ready to go on to the rotary profiler. We'll use maple neck blanks on anything from some of the Melody Maker models to some of the Les Paul models. This is the rotary profiler that we're using to process the necks. So you can see the neck blanks are rough bandsawed to size, similar to the body operation that we saw, so it just removes a lot of the excess. and they're loaded onto the rotary profiler, which will further shape the backs of the necks, get them down to a more manageable size, cut the peg heads down, and kind of rough it in closer to the finished size. As it goes through the operations, there's actually a couple different operations happening where he'll take it out of one fixture as it cycles through, and then he'll pick it up and it'll be clamped in another fixture, which will do another operation. Different gang drills for different peg heads are used. So you can see here there's 6 in a line, which
like
would be for Explorer, Firebirds, and guitars of that nature. And then the 3 and 3, and some of the 3 and 3s could be for different size peg heads. We have an SP1 and an SP2, which are slightly different layouts, but still the classic Gibson kind of design. So you can see he's using a shaper table with an incredibly large cutter on there. And he's roughing in the neck with that. You can see the peg head coming down to shape. That's another old school method. Again, depending on the model, determines on what gets what process. You can see that the neck is clamped to the pattern, and the pattern has a guide that it follows.
So at the bottom of the bit, there's something that moving along the edge of the pattern and the base of all this.
The bearing on the bottom of the cutter. Right now we're watching the truss rod assemblies installed in necks. It's a conventional compression rod that we've used for years. Now it's so widespread, virtually every company that makes guitars uses a truss rod, and that was actually a Gibson invention. So he's installing, after the rod, he installs the spline, which is the strip of wood that presses down on the truss rod, and that's glued in and clamped, and then profiled down.
So that it's flush with the rest of the neck?
Correct, and then the fingerboard can be glued on. Here you can see the clamps. After the truss rod splines are glued in, they're clamped in all these clamps here.
Now we're in a different building than the mill we were just in. This is where the bodies and the necks come to be put together with the other components, sort of the more finely tuned stuff. And we're starting out looking at a big pallet full of fretboards, right?
Yes, this is called Granadillo. It's a Guatemalan rosewood. We're using this on various models. Very similar to rosewood, but a little harder. Color is very similar. Grain can have a little bit more figure. So it's kind of in between a conventional rosewood and ebony. A little bit brighter than rosewood because it's a little bit harder, but not quite so much as ebony. From there, it's going to go into another one of our kilns. And once the moisture content is stabilized, then we'll take it out of the kiln, and then it will be run through the processes. Here we're gluing in the top dots and the fingerboard inlays. So again, it's one of those operations that just has to be hand done. These are acrylic top dots that he's gluing in. We'll use acrylic, and we'll use plastics and sometimes wood. This is the small block inlay used on our SG. It's a little bit smaller than the Les Paul Custom or CG style block. So the glue is applied, and then she's hand inserting the inlays in, and then they'll be tapped in and allowed to dry. After the fretboards are radius, they're run on the fret slotting machine. You can see it's a turret style affair where the pneumatic clamps and all the fingerboards are loaded onto the machine. And as it rotates through, there's a arbor with various saw blades that slots all the fretboard slots at one time. So it just cycles through. You can see our different arbors for different scale lengths, various guitar scales and bass scale length. Long scale bass, short scale bass, and then we use primarily 24 3/4, but we also do some models with 25.5-inch scale. Here we're looking at our fretting operation. We have the frets are tapped in by hand to get them located in the slot, and then the hydraulic press comes down and presses the frets in place. After that, they're trimmed, flushed with the edge of the fingerboard. After that, some models that have binding, the binding will be applied, and then other models that don't have binding will proceed on. This is an RFID tag that is installed on all our guitars. We do this to allow tracking throughout the facility, and for us to monitor that everything that leaves the door is accounted for, and as far as inventory, and allows us to also verify. We could verify internally here whether it's a guitar that we actually built here. After the fretting operations, the necks are prepared by getting the peg head veneers glued to the faces. You can see here they're loaded into a pneumatic clamping fixture. after the glue is applied, and then they're clamped until ready to process. After the peg head veneer is glued on, then it'll move across the aisle here and have the fingerboard glued on. The fingerboard has glue applied, and then it has locating pins that locate it on the neck, and then it's loaded into this pneumatic gluing fixture. So it's kind of like a series of fire hoses. So instead of using one clamp or a series of clamps, you have one clamp that's a pneumatic control clamp that applies the air to these fire hoses that press down on the back of the neck. Again, it's a lot more consistent pressure, which gives it a lot better clamping operation than a series of clamps. Another one of our NC machines that we use here, our neckline carver is done. Some necks, even though they're machined at the other facility at the rough mill, they may have additional neck carving operations done here, such as maybe a final peg head shape or the back neck profile. Some models may be common at the other plant, but once they get done at this operation, they be more model specific. So once the fingerboards are glued on and the peg head veneers are glued on, the nuts are glued on, all the other prep work is done on the necks, they come over here and they still have a sanding operation that has to be done because you have tool marks, or the edge of the neck that extends from the fingerboard has to be flushed up. So a lot of that is still done by hand, and these, again, it's a highly skilled hand operation. After the bodies are machined at the rough mill, they come up to this department and they're run through various sanding operations. It could be edge sanding or fine sanding the top contour or the back profile. Some models then that have binding, the binding would then be rabbeted, which is the routing around the perimeter to a channel for the binding, and then have the binding applied. Each station is kind of specific to that operation. So you have a slack belt sanding operation that would be used on a Les Paul where it's contoured on top. So the big slack belt is flexible enough to allow the operator to press that sanding belt across the contour of the top. Some sanding operations may have what we call a rolling pin sander, as it looks like a sanding roll on a pneumatically controlled spindle, and that allows the operator to kind of get in all the nooks and crannies and irregular surfaces around the perimeter of the guitar. Here we're watching the binding be applied. As you can see, it's a very old world method of applying the binding. Gibson's done this ever since they've been applying binding. It's one method that Gibson's kind of known for. It's like a canvas rope that we'll use it again repeatedly, and at certain points it has to be replaced, but you can get numerous uses out of it. And it's just wrapped, as you can see, very tightly. The glue is applied to the binding, and they start the wrapping process. They'll get that first wrap done and locked in, and then they just start wrapping it, going around the body perimeter, kind of like you're wrapping a cheese wheel. Body binding is a ABS for most bindings that we use. The glue needs to be able to melt into that material and bond it to the wood. So it has to, that glue is specific to this operation.
So how long do these hang on these racks here?
Once they're wrapped, they'll hang overnight. So they have to completely dry thoroughly, and that's just the nature of that glue. Here we're at the neck fitting operation. You can see the glue's already been applied, and he's clamping it in. Now he's taking a toothbrush with some water and wiping off all the glue residue. Prior to that, the neck heel, if needed, it has to be chiseled. Again, this is still a very old school, labor-intensive method of doing a neck attachment, but it's really the best way to do it.
It has to be eyeballed because every piece of wood is a little different, may have a little tiny lip here or there.
Yeah, even though the neck and the body are both NC machined, you still have to hand fit each individual one for a proper fit. Sometimes you may have glue swelling or shrinking, or maybe through the process it just needs to be fine fitted for a proper fit. So he'll make sure that it's flushed off on all the surfaces and then fine fit the neck to the body. After the necks are attached, they're put on this carousel, so it gives them a place to dry, and it's very space efficient. Once they're dried, then they're put on racks, given another inspection, and then sanded on the spindle sander here to flush up the neck with the body joint. At this point, what we do here are the pickup cavities and maybe bridge location and different bridge cavities. In the case of, most of our models will use a stop bar and tune-o-matic. Some of them may have tremolos. Some models, like say we have a Les Paul that could be common up to this point, this routing operation would determine which model it is. Here we're in the Plek room. We have 8 of these Plek machines that dress the frets and polish the frets. So the instruments are loaded in. We have various fixtures depending on the model that will hold them properly in the machine. They're scanned to find out, if frets are high or where they're at. After the scanning process, it will then go back one by one and level and crown and polish all the frets. Completely computer controlled and very accurate.
How long does it take to go through the Plek machine, the entire process?
The entire process is about 10 to 12 minutes. After the instruments come out of the Plek room, in color prep, all the final sanding is done and all the wood filling prior to being allowed to go into the finishing department. So again, depending on the model and on the color, when it gets into the wood filling, we may have a cherry wood filler or a walnut or a natural, and that is basically kind of a milkshake thickness wood filler that's applied to the wood surface and kind of rubbed into the grain to fill the pores of the grain. For one, it highlights the grain and makes it kind of accented in the finish operation, and it also packs the grain pores to prevent the finish from sinking into the wood grain. We're entering our finishing department now. Right now we're in the scraping and in-between coat sanding area, but you can see the guitars, they're in the middle of the finishing process. You can see the guitars on the carousels cycling above us. So in between coats and operations, they ride on that carousel where it's warmer, and that helps the finish cure. And it in terms of material handling, is a lot more efficient than keeping everything on one level and less actual physical handling.
How much time does each guitar spend on the carousel going along the ceiling?
It depends on the finishing operation. Some finishes, in the case of a high gloss, the entire process time may be 4 to 6 days in terms of actual finishing, and then there's dry time. Some finishes, in the case of our satins or worn finishes, may get a few coats of satin and a color coat, and they may be in and out of the finishing area in a day or two. She's measuring the film thickness on the finish build. It's another one of our QC steps within the department. So we will spot check and monitor within models or batches the material thickness to make sure that not too little or not too much is applied. You don't want it too thick. The thicker the finish, the less the wood is going to vibrate. Too thin, it's not going to last. It has to be durable. That's certainly a valid point there. And within processing, it has to be thick enough to withstand buffing. So you have to have enough material that you can sand it and buff it. We still do that with silk screen, just like we did in the old days. Some models will have a silk screen application, and some models may have, a mother of pearl or acrylic inlay, just depending on the model. But in the case of our classics, where it called for silk screen, we still use silk screen. Here Ray is actually doing a sunburst that he's doing by hand. You can see it's a very skilled operation. You can't automate that kind of thing.
So are all of the sunbursts done by hand like that?
Yes, everything we do and we have a variety of sunbursts. So not only do you have to be on top of the model, being that it's a hand operation, you have to get a feel for how that spray gun has to be angled and held on a particular model. And then you have different colors. Here we're doing the VS, which is a tobacco type brown. Some shades are iced tea or cherry and variations of each, where they're a lighter color and it requires a different skill or a different feel to be able to apply those sunbursts. Here the guitars are having the top coats hand applied. After they get the sunburst on or shading, they'll get a seal coat of clear before they get on the electrostat line. All the operators here are hand scraping all the binding on the bodies and fingerboards. So we don't mask anything. With the nature of our finish, it really has to be a hand-scraped operation. Very, very highly skilled and very detailed. She's using a scraper blade, and they have to keep those sharpened, and they'll replace them. You can see the files where they sharpen their blades numerous times, throughout the day, or as needed. The training is very difficult because you have to have such great eye and hand skills, and a lot of these folks have been here on the line for years and years. After finishing, the instruments are brought into the neck prep area, and here what we're doing is removing any finish that may overlap onto the fingerboard. Even though it's masked, you're going to have a little bit of residual finish that needs to be cleaned up. As you can see, they're scraping the finish off the very edges of the fingerboards. Very meticulous, absolutely right. And after they do the razor blading operation, then they come back with steel wool and then polish the fretboard and the frets with the steel wool, which further removes any tape and finish residue. So after the guitars are processed in the neck prep area, they're brought into buffing, and at this point they're buffing out the finishes. You can see they go through 3 successive grades of buffing compound, starting with the red wheels, that's the coarsest, going to the yellow and then to the white buffing wax. And each wax removes the scratch from the previous wax, and what we're doing is sanding and buffing out all the imperfections in the finish, all the orange peel that is just part of the finishing operation is fine buffed here and given its final luster. In the center of the room we have our final inspectors, and as the buffers put their guitars in the racks upon completion, the inspectors then pick them up and look for any scratches or any issues that may necessitate them to get buffed again, or if there's a finishing problem that they discover at that point, then it will have to be refinished or repaired. After the guitars leave the buffing department, they're brought in here. They're given another inspection and cleaning here. We clean and oil the fingerboards, and we also give the guitars a final polish and inspection before they're issued to the line for assembly. Here is where we wind and build all our pickups and all our control assemblies. They'll generally load up about 10 pickup bobbins to be wound all at the same time. That ensures it's a lot more accurate and efficient at the same time. We've been making our PAF humbucker style pickups pretty much as we've done since the 50s, only now they're a lot more accurate. We've, over the years, have gone back and done various reissues. Those are all the same. When you're winding the pickups all at the same time like that, they're all done to the same number of turns, and so you want to use the same gauge of wire. In this case, they would be PAF styles. Even within the humbucking, we'll have dozens of varieties of winds and wire gauges that we use. Now you can see the coils all being wound at the same time. The count, the turns are automated, and the traverse, which is the side-to-side motion, is all automated, so everything is as accurate as can possibly be. After the pickup bobbins are wound, the pigtails, which are these short wires, are attached, and then the pickup coils are taped up. At that point, then they can go down the line and then get built up and assembled. They'll install the pole shoe, the screws, the magnets, and the base plate. After the pickups are completely assembled, we'll give them a wax potting operation that allows the wax to permeate the pickup assembly. The idea is that the wax can penetrate the coils and prevent, once it's cured, will prevent the coil from vibrating, which is what causes feedback. So it makes the coil less prone to feedback and a lot more durable because it's going to be less susceptible to any kind of moisture that could cause any kind of oxidation within the coil and just dampen any kind of vibrations. Here we're building up all the control assemblies. We have various stations. Maybe at one station we install leads onto pickup selector switches, and then we may have a station that installs all the pots onto the control plate assembly. Step by step it just gets built up all into the complete electronic harness. After the guitars are given their cleaning and fretboard cleaning and oiling, they're issued to the line, and here you can see the line. The guitars are built up in various stages. They're installing the tuners, the bridge, the electronics, and all the various components until at the end of the line they're ready to have the strings installed and tuned and the setups. So once the guitars are primarily assembled, then they get over here and the setup guys will then install the bridges, tailpieces, and strings, and then give them the preliminary setups. Here we're in the final cleaning and inspecting department to get the final cleaning and inspection and truss rod cover installation and back control cover installations. We leave them off until this point so we can get in and clean all the nooks and crannies, and we also do any kind of spot buffing or shining that may have to happen. We're here at final inspection. RP is one of our final inspectors that has been here for 19 years. He has a great deal of experience. So he's looking at not only the playability but the cosmetics and running any kind of quality controls. If something doesn't pass, he'll flag it and stop it, and it will have to be dealt with accordingly depending on the situation. He'll test everything from the electronics, function, sound, and playability, action height, pickup height, neck adjustment, and all the finishing quality control that needs to happen. He's doing a bend test right now, so not only will he play the notes all up and down the neck, but he'll bend them just to make sure that there's not going to be any notes choking out during bends. There he's initialing the tags, so after inspection they'll initial it. So that's their sign off that everything is okay. Then it can proceed to get put in the warehouse and packed or stored until it's ready to get packed and shipped.
Jim, thanks so much for taking the time to show us around the whole factory. It's been really cool to see all the different steps and see so many drill-worthy guitars. I'll take one of them. Now, anyway, thanks again, man.
Thank you. We're glad to have you. You're always welcome back, and we enjoyed it too.
Cool. Thanks, man. For more information on Gibson guitars, go to Gibson.com. I'm Sean Hammond. Thanks for watching PremierGuitar.com.